In this video, we're going to go over section 6.1 from our textbook, which just talks about the area between curves. So this video might be a little shorter. We're just going to do a few examples of this. But first, let's look at this here. Consider the area bounded by some function f of x and some function g of x, where f of x is bigger than g of x, and both of these guys are greater than or equal to 0. And this is for some interval where x is in between a and b. Now this is shown in this figure here. We have our curve f of x here, our curve g of x here, and our interval a to b here. So the area between f of x and g of x is given by this shaded blue region here. And we can find this by taking the area of f of x. So the area under f of x is going to be this entire region here. And then what we can do is subtract out the area under g of x, so this entire region here, and that leaves us with this remaining region here, this area. So we'll do exactly that. The area between our two functions is going to be the area under our function f of x, and then taking out the area under our function g of x. And we know that the area under our curve f of x is given by the definite interval here, and same for g of x here. So this brings us to this formula here for finding the area between two curves. Now, this result does not require our functions to remain positive over some interval either. So a more general result is given by this here and shown in this diagram here. So again, if f and g are continuous and f is greater than or equal to g over some interval, then the area bounded by our two functions and this interval here is given exactly by this guy here. Now this is only the case when f of x is greater than g of x. And graphically, that just means that f of x is above g of x. So let's look at an example here. We want to find the area bounded by this function here. Y is equal to 0, so that's going to be the x-axis, and x is equal to -1 and 3 here. So x is in between these guys. So graphically, this is what that looks like. We have our function x squared plus 1, so that's given by this parabola that was translated 1 unit up. Our y is equal to 0 is our x-axis here, so this green line here. And then x is going to be in between -1 and 3 here. So we're looking for the area bounded by those guys, and so that's everything in this shaded region here. So the area, using our formula that we just discussed, is going to be the definite integral, where our lower limit of integration is -1 and our upper limit is 3. And then it's going to be f of x minus g of x. In this case, f of x is x squared plus 1. And then our g of x, our second function, is just y is equal to 0. So that's the x-axis. So we don't need to have anything there. We could write -0, but we don't need to do that. All right, so all we need to do is take the integral here. We'll find the antiderivative of this guy. We know that's going to be x cubed over 3 plus x. And we know we want to evaluate this at the lower and upper limits there. So doing so, we'll get 3 cubed over 3 plus 3 minus -1 cubed over 3 plus -1. So we'll get 27 over 3 here plus 3 minus, this is going to be a -1, so this will be a plus here, 1 over 3 plus 1. Right, this is a minus here, but this minus applies to this guy here, so we get plus 1. So rewriting these guys with a common denominator, we have 27 over 3 plus 9 over 3 plus 1 over 3 plus 3 over 3. So in this case, we find that the area bounded by our f of x, g of x, and in between these guys here is going to be 40 over 3. All right, let's look at another example here. We want to find the area bounded by this function, x squared minus 1, this function g of x, negative 1/2 x minus 3, and the lines x is equal to negative 1 and x is equal to 2. Okay? So that's what this looks like here. In blue, we have our function f of x. I'll label these guys. That is our parabola that's shifted down 1 unit. In green, we have our function g of x here, this line. And then we're looking at the area bounded by those two functions and these two lines here, negative 1 and 2. So that's these two lines here. So we're trying to find the area of this shaded region here. Right? So we know the area is going to be given by the formula here, where our lower limit's negative 1, our upper is 2, and we are going to take the difference between our functions f of x and g of x. So this will be x squared minus 1 minus, we have negative 1/2 x minus 3. So before we take the antiderivative and evaluate, we can simplify this a little bit. So we have x squared minus 1. This will be a plus 1/2 x. And then a plus 3 here. So we can combine. We have this minus 1 and this plus 3 here. So we're left with x squared plus 1/2 x plus 2. So now we can find the antiderivative of this guy and then evaluate at our limits of integration here. So this will be x cubed over 3 plus we have 1/2 and then x squared over 2 plus 2x, and we're evaluating this at negative 1 and 2. Doing so, I'm going to need more room, so I'll write it over here. We'll get 2 cubed over 3 plus we have 1/2 and then 1/2 is our coefficient for this x squared here. So we'll write this as 1 over 4 x squared. So this will be 1 over 4 times 2 squared. And we'll get plus 2 times 2 minus, this will be negative 1 cubed over 3 plus 1 over 4 times negative 1 squared plus 2 times negative 1. Alright, and then evaluating this, we'll get 39 over 4. So that is the area of this shaded region here, bounded by these two curves and these lines here. Now the last problem we're going to look at is we want to find the area bounded by this function, and for x values in between these two guys here. So, looking at it graphically here, we have our f of x is our parabola, and our g of x is this line here. So this parabola looks like this here, and we have our function here, and we're looking at x values in between negative 2 and positive 2. So notice that's everything over here and over here. So the area in between these curves and bounded by these guys here is everything in these two shaded regions. So now we have two different regions. Okay? So what we'll do is we will split these and evaluate them separately, and then to get the total area, we'll take the sum of those two. So what I mean is, we'll look at the area first of A1. Now in this case, remember when we're using our formula given by this guy here to find the area between these two curves, our function f of x needs to be greater than g of x in order to do this, because again, we're taking the area under this one, our greater function, and subtracting out the area under our smaller function here. In this case, we're looking at A1 here. G of x is actually bigger than our f of x, our parabola, in this region. All of our output values for g of x are bigger than our output values for f of x. So in this case, these are going to be our limits of integration here. Actually, our limits of integration are going to be -2 to 1, because we're just looking at this region, A1. And in this case, g of x is bigger than f of x, so it's going to be 4 minus 2x minus 2x squared. So taking the antiderivative of this guy, we'll get 4x minus 2x squared over 2 minus 2x cubed over 3, and we're evaluating this at these limits of integration here. Doing so, we'll get 4 times 1 minus 1 squared, because these two cancel, minus 2 over 3 times 1 cubed, minus 4 times -2 minus -2 squared, minus 2 over 3 times -2 cubed. Doing this, we'll get 9 here. So this tells us the area between these two curves bounded by -2 and 1 is going to be 9. Now we'll do the same thing for the region here, A2. In this case, our limits of integration here is going to be 1 to 2. So the area between these two curves now are bounded by x is equal to 1 and x is equal to 2. Now in this case, notice that all of our output values for f of x here are greater than all of our output values for g of x here. So in this case, when we're taking this integral, we will have 2x squared minus 4 minus 2x. Alright, so simplifying this a little bit, we'll write this as 2x squared minus 4 plus 2x. So we'll take the antiderivative of this guy and then evaluate at those guys. So this will be 2x cubed over 3 minus 4x plus 2x squared over 2. And we're evaluating this at our lower and upper limit. Here we'll get 2 times 1 cubed over 3 minus 4 times 1 plus, this will just be 1 squared since these guys cancel, minus this guy here, minus 4 times 2 plus 2 squared. Right, and then evaluating this, we'll get 11 over 3 here. So this tells us the total area between f of x, g of x, and for x values in between -2 and 2 is going to be equal to the sum of the area in the first region plus the area in the second region here. So this will be 9 plus 11 over 3. And then this will be roughly equal to 12.67. Alright, so that'll be it for this video.